to log things within your programs. And based on simple change to a configuration file, you can have it log very detailed information about what transitions are firing, for example, or very abstract information, just letting you know when it's started running, maybe opened a database connection, maybe stopped running, etc. So logging's a good thing. Putting in assertions to check your assumptions. Naming things carefully, very, very key for communicating. Using functions to break up your functionality so you can actually give it a nice name as a function rather than just putting down code and copying and pasting it. Where needed, you can just call the same method. You can use type checking rigorously using enums, for example, to capture values rather than simply numeric constants. Instead of 0 and 1, have male and female. Using enums in Java, this is a very good thing. And generally using good principles of software development to create classes and methods where appropriate. So there's a bunch of good technical guidelines that can be applied. But I'm going to talk here about process guidelines. And at least one person in this class has taken my class 371, where I really emphasize these components. From my experience, these things are absolutely critical to an effective software project, and they're very, very important to an effective modeling project, even a smaller one. So one thing is peer reviews, and we'll talk about that a little bit. Ongoing testing of your model. Test it out. Test it with extreme values to make sure it behaves as you think it will. You know, with values that are 0 for transition, make sure it behaves as you expect. Preserve successive distinct model versions. Don't just overwrite your model versions. At the very least, name them successively so you can go back to them if required. Better yet, put them in a version repository. Keep careful track of your experiments. This may mean a lab notebook or an electronic version of a lab notebook so you can record and reflect on what happened earlier. That can help you track down bugs. Where did a certain bug creep in, for example? You can use tools for documentation and referential integrity to make sure that you're maintaining the papers on which your model, to which it's referring, or documentation for the model is made consistent with the model. And you're going to want to integrate with other people's work frequently in small steps. And you're going to want to use a very incremental process. And probably this is actually worth putting. So use incremental model development. This is one of the key principles I'd like to emphasize. It's something I emphasized early in the term, but maybe now that you're working on projects, you'll understand this. Avoid the desire to go for the big bang. Build it up step by step by step for several reasons. One thing is, if something goes wrong, you know where that problem crept in, or at least you can bound it more likely. You only saw the problem after you added this certain thing. So it's quite likely that it was caused, or at least triggered by, made visible by that thing you changed. And that will give you a big hint as to what the problem might have been. So one thing is, it lets you discover more quickly where something went wrong. Another reason is it's something you could show to someone to get feedback along the way. Could be me, could be your client, others who are expert, other members of your team. Another reason to use incremental model development is you can check the behavior of the new model against the previous model, making sure that they give similar results when similar assumptions are used. So if you've added one thing in, you might disable that thing and make sure it still behaves as it did before, and then enable it. Or you enable it with a value of 0 for a certain transition. Make sure it behaves accordingly. But in short, you can, as I heard one person describe it, dock it against a previous version of the model to make sure that it's consistent. And that really eases the whole process. Another thing is it's just a lot more motivating to this. And finally, it's a lot easier to test. You can write tests just for the thing you've added in. How would I create tests in AnyLogic? Well, one way to do it is to create experiments that are dedicated just to exercising the model with certain values that you know should exhibit known behavior. And make sure that with those assumptions, it exhibits sensible behavior. Okay, we're going to talk about a variety of these things. Here's another meta principle. When you discover this goes well beyond this class. It's a general principle about software development and even more broadly about life. When you find a problem, it's good to fix that problem soon. And you should pride yourself on fixing problems soon rather than castigating yourself for having made that mistake. You should just try to fix it. And then you should ask, what can I learn from this? What can I learn from discovering this issue? And that learning should be as much about the process side as it is about the technical artifact involved. Sure, you want to fix the bug in the artifact. You want to fix the fact that you divided by a parameter rather than multiplying it. That's valuable. But you should ask yourself, what was it that left me vulnerable to that? What left me so I didn't catch that earlier? What is it that caused this in the first place? Is it that I was too tired when I was doing this? Is it that I was confused about the nature? Do I need to study better sort of under what cases we do each of these? Was it simply someone else was modifying this and I didn't cross-check it? Why didn't you catch this, earlier in an earlier review of it? Was it because you weren't looking systematically throughout the model, etc.? So you should use discovery of bugs and oversights to find opportunities to improve your process, improve how you test the model, improve how you help develop confidence in the correctness of the model. And this could include, doing better peer reviews or doing peer reviews in the first place. It could include more effective testing. So peer reviews are a particularly key thing. We'll talk about them. Version control. Well, I spoke about these earlier. So let's talk about a couple things here. Additionally, we'll go into more detail. So one thing is AnyLogic comes with the ability to generate documentation on a model. This may not have been obvious to you, but if you you right-click on a given model and you say create documentation, that will actually go and create a summary of elements of your model, particularly those that you've modified, okay? So one of the things that a lot of people complain about AnyLogic, and I will sometimes complain about it too, I think it's a problem, fly in the ointment, is that code is scattered all around. There's code, and it's scattered in different places. Some of it's in the person class startup. Some of it is in the, experiment. Some of it is in the associated with the transitions, etc. And it's easy to forget where that is. If you do generate the documentation for a given project, that can give you an overview of where all your code is within the project. And that's useful. It helps remember where you've put different things. That can be particularly key to look at from time to time because you may have forgotten, for example, to systematically go back and reset a change you made to run an experiment that you meant to check back, but you got distracted by a phone call or an urgent message or lunch, and you forgot to change it back. So going through and just reviewing that periodically makes sure you're dealing with the model you think you're dealing with, not one where you disabled something and forgot to re-enable it. So here's selecting documentation output. You can get output it as PDF, for example. And this is some example documentation. You'll notice that it has a bunch of different sort of settings that you would have set, some of which you may not have really thought much about. Let's talk about incremental delivery, starting simple, building up incrementally. Innovate off of simple experiments. Yeah, so we talked about some of these things. Incremental delivery is particularly attractive because, for reasons I didn't emphasize, you always have something to deliver, or almost always. No matter how far you get, you have something, and that's useful. Talk about continuous integration. So if you have a multi-person project, integrating each of your components on an ongoing basis sooner rather than later is really desirable. Rather than going off and each developing pieces of it for weeks at a time and coming together, it's better to exchange your components sooner. That lowers the chance of misunderstanding between people, helps make sure that each of your components will fit together and articulate well. And continuous integration has been one of the big advances that has industrialized software development in an effective way. It is helpful to do this within version control systems, particularly. So there's lots of advantages coming from continuous integration that I don't have time to cover here, but it can be quite enabling in terms of team morale and in terms of avoiding really hairy sort of problems that occur when you have disparate people's projects come together. Each of them may have made a perfectly reasonable assumption, it was just a different assumption. And you only discover it late in the process, and you have to go back and painfully sort of adjust major components of the code. So I want to talk about managing process complexity. Turns out that building a model, when you run a modeling project, it itself is a somewhat complex process. You have a lot of different things going on. You have versions of a model. You have the assumptions associated with different versions of the model and the sources of those assumptions. They may be papers, they may be discussions, etc. You have outputs, you have scenarios that you run with particular versions of the model, and you have outputs from those scenarios, and potentially analysis of the outputs from those scenarios using tools like R, or Excel, or other tools for statistical analysis. And basically, these projects generate a large amount of information and versions of artifacts. And if you don't manage this effectively, you may find yourself drowning in outputs from these models. In graphs from earlier model runs, you're not sure exactly what the assumptions were. You're not sure exactly what version of the model was used to produce it. This is a big problem. If any of you end up doing modeling at a professional level, either as in an academic setting to answer questions, or externally on a consulting basis, and there's plenty of needs for modeling consulting out there. If you find yourself doing it, it's essential that you manage this complexity effectively, because if you don't, you will lose credibility among clients. You'll be unable to reproduce results that you submitted previously in a paper because you've now overwritten that version of the model. And that's a big problem. You need to be able to have this be reproducible. And issue is there's some important gaps in existing software support. So AnyLogic does support subversion to a certain degree, but the ability to collaborate, for example, on particular scenarios, or for different people to add scenarios is quite poor right now. And the ability to maintain metadata in conjunction with models, sources of parameter values, for example, or outputs from model runs, is kind of poor. And this is important. It's important for process transparency, confidence of those using model results, limits on project scope. Okay, I mentioned some things with testing. The two primary vehicles I have used for testing are, number one, scenarios. So you have scenarios that are set up to test the model under certain conditions. Very small populations, extreme values for certain parameters, for example, if you set the recovery rate to the average time to recovery to be something very, very large, say 1 million days, does the model behave as you'd expect it would, with no one recovering? If you lower the infection rate very, very to 0, are people still getting wrongly infected? That's one way. Second way is there's this tool called JUnit, and it's for unit testing in Java. You can use JUnit to do some testing. The problem is that JUnit can't by itself instantiate agents, for example. The agents have to live within some sort of active object, like a main class. And JUnit, unless you explicitly do a bunch of work, which I've never done, it's not going to be able to directly, your JUnit tests are not going to be so easily able to create this, to create effective test harnesses for testing these things. What you can do, though, is use JUnit with certain test methods that are used to check the consistency of certain, for example, certain agents. Make sure they're in a sensible state. They're not dead with respect to one state chart and alive with respect to another. So you can create test-specific methods that are in the agents, for example, that check to make sure that things are sensible with the agent. The agent's age is not negative. They are either alive or dead, and not in some weird combination of them. They are located within the bounds of the space. It checks various invariants such as that. A lot of work still has to be done in this area, and I know you've been thinking about this, about how to effectively test these models. And there's some learning to be gained there, I think, from some of the work you've done. Prototypes. Prototypes are really useful to build if you're uncertain about how to proceed with a modeling project. Try creating what's sometimes known as a spike prototype in software. You do in a focused way, you just try out an idea. And the goal is not to start creating a model like that. It is to just try out an idea, see what it would look like. And you might prototype 2 ways of doing something and see how ugly each of them is and choose the least bad ones. Often these are done for user interfaces in software, but they can be done for many other areas of software. And if we're building models, they're really useful to do. If we're not sure how to proceed most effectively, try modeling it in 2 different ways and see which is easier, which is better. One thing I wish I could recommend, and this just reminded me of it, but I'm not aware of a way to do it right now, is mocking. So this is an idea I think Dylan will be aware of. Some of the others of you from software engineering who have had software engineering exposure may be interested. This is something which I have encouraged the software developers to incorporate, but mocking basically consists of an easy way to create fake versions of an object, where that version of the object is used for testing. It's used for consistency checks. It's used for having a very well-defined behavior. You know what it is associated with that object, and you can then have other objects interact with that one. So, for example, you might mock up an instance of an agent that maybe would even then continue and call off to the regular agent, but would automatically record all calls made to the original agent. Or it would record all uses of that agent by the main class. Mocks are very useful for testing. They're very useful for debugging of a system as well. And unfortunately, mocking is not supported right now within AnyLogic. Be an interesting question about whether you can make a Java-based mocking framework like Mockito or JMock work with a tool like AnyLogic.
It does work.
It does?
Yeah, so Mockito works. works in there. And it does make testing easier to some degree, but the biggest barrier to testing AnyLogic code right now is it's not obvious how to create agents on their own.
Right.
It's not obvious how you need to have the engine instance that you pass to them configured. So you can do your own classes relatively simple, and then you can give agents an interface and then lock that and pass it to your other classes, but it's still primary.
Yeah, it's this whole issue of test harnesses, right? You're not able to create test harnesses other than experiments, which pull to create test harnesses which create agents, basically, or create a main class without agents and kind of frob it to make sure that it's consistent. And until one has a way of instantiating sort of a full test harness without the full infrastructure of an experiment. I think experiments are kind of the least bad way to do it. They're really sort of the only way you can do it. But you end up twisting them in kind of weird ways to try to use them as testing frameworks. So just with an eye towards time here, I want to talk about a couple things. One is peer reviews. So we've used peer reviews in my group for models to very good effects. The idea with a peer review, folks, for those of you who are not familiar with it, this is not about reviewing peers. It's about reviewing artifacts, several peers coming together and reviewing an artifact. And the goal is to keep the attention on the artifact. It is not to find out who is to blame so much as to learn from the artifact about what we could do better, what things may need to be fixed in the artifact, what things may need to be fixed in the process. Reviews are one of these things which is viewed as an industry best practice in software development. It's actually more cost-effective than testing. It can find more bugs and can find them in less human time per bug. It tends to easily pay for itself in formal studies when inspections, a formal type of peer review, are done. And it's actually more flexible than testing, because you could review for a model, folks. Well, tell me some things. What could you review for a model? So obviously, I could give you a certain model and say, could you look at this and comment on it? And that's really useful. And if we got together a group of us and we said, okay, Molly, you're the presenter, Dylan, you're the reader, and Shin, you're another reader, and Steve, you're the moderator, and you're the recorder. We could do that, and that would be closer to a formal inspection, although there's some other elements of that. But what sort of things besides a final model might be reviewed usefully in a modeling project? Besides, the actual model that comes out from the process. What things could be reviewed? Particularly what things could be reviewed earlier in the process?
The way it's structured and how efficiently you've created your variables.
Yeah. So early on, you might have identified who are the major agents, right? And someone could comment on that and say, well, I see that you have persons, but you don't want to represent health personnel also, or do you really need to represent 5 different types of agents? Couldn't you do it with 3 and treat 2 of them as more or less, or 3 of them as more or less variations of the same thing? So you could do that. You could we can draw out state charts without having parameterized them. We can just draw them out, use them to illustrate what we're thinking in terms of the division of states someone could be in. That's a useful thing you could review early. You could review a scope document. What are the 3 big sort of divisions in terms of scope that I mentioned early on in this class for a model? When you're thinking about a model and you think about whether some phenomenon is going to be in the model, what are the 3 possible ways that you could answer? It is endogenous. It's simulated in the model. Those dynamics are captured by model mechanisms. And that's powerful because that means if we change parameters, we can see changes in this thing. That's the most powerful way. But another way is it can be exogenous. It's still in the model. It's in the model in a fixed way, with a fixed set of assumptions. Maybe exogenously we assume some economic, downturn and upswing, or we investigate several of different ones of those. Those would be exogenous. We're not calculating that. We're just imposing those assumptions. Finally, it can be explicitly and consciously ignored. We thought about it. We decided we don't want to put in the model yet. We're not convinced it's required, or at this stage, we don't want to have to worry about it, the complexity. We're trying to learn one step at a time. So we leave it out of the model consciously for now. We don't represent it at all. We could review a document of that sort and reflect on it and say, well, is this appropriate, or do we really need this thing at least exogenously represented? That would be something that's useful to do. And that would be something a peer review could be used to do. It could review test documents. It could review, plans in terms of schedule. It could review interactions between agents without looking at the code, sort of a description of these things early on, before code is ever written. For Venn models, could, review the breakdown in terms of subscripts and what you're planning to incorporate. So it turns out early reviews have a disproportionate benefit. Doing reviews early in the process buys you a lot. It allows you, for example, to avoid whole rat's nests of issues, going down rat holes, and instead steers you clear of some troubles. Early artifacts have a disproportionate process. And this can include, in general software, it might include a lot of additional features, but a lot of these apply even here. And there's benefits to peer reviews to go well without the model. Imagine you do a peer review and everyone forgets. UA's notes as recorder of what comes out of the peer review are burnt up. They're suppose they're destroyed for some reason. Suppose that all people forget what went on in terms of actual bugs found in the artifact. There's still been learning about the process. Clarifies understanding of how AnyLogic works, how clever ways to do things within AnyLogic, stylistic ideas, how to represent things clearly visually, how to color things. Some of the most beautiful models I've seen have been literally beautiful. People take model things like state charts, and they lay them out really clearly, and they color them in a really compelling, consistent way, and that adds to our understanding. It adds to our memory of how to navigate the model, where things are found, etc. And these are the sort of things you might learn from a peer review. Person whose artifact is being reviewed learns how to improve their technique and process, and it leads to a spread of knowledge more generally. There's a lot of guidelines for reviews that I don't have time to cover here, but these will be in the slides. These are from Carl Wiegers. Wiegers' great book on peer reviews. And what you'll find is there's a formal type of review called inspections. And inspections have a set of stages associated with them that begin with a preparation stage. Even before that, there's a planning stage. So people review material on their own before the meeting. Moderators assigned up front. People assigned on roles. There's people invited, and there may be an overview given of the artifact, and people reviewing a formal inspection package ahead of time, and then they come to the meeting. And inspection summary reports, issues logs are created. Dylan has noted the therapeutic value of towel folding. The issue here is that the models have have a real need to keep it impersonal. And this is a challenge because you're often describing things you put your full efforts into, and a lot of issues come up with them: mistakes, oversights, inelegant things. And if you can keep it impersonal, that's often a key to having it work successfully and having learning really go more than skin deep. So within a review, there are tricks that can be used to kind of keep the focus on the model and help lower the risk of it being a stressful affair for everyone. And I think actually the TOEFL is a very interesting one. Having someone, it doesn't have to be TOEFL, it could be some other activity that goes on during it that provides an alternative to sort of just worrying on the part of the person whose products are being inspected. So there's a set of stages. What's notable here is that there's a rework stage where items are actually fixed, and then they are updated, and there's a follow-up. Often the moderator would decide, okay, have the changes in fact been made and confirmed in terms of the shared repository? Say the model has it been updated properly and so on. Finally, there's an element of causal analysis that uses the inspection process to try to figure out what was the root cause of this defect. Do we need to have more training that goes on within our group? Was there miscommunication between people? Are we pushing people too hard? Is there too much reuse of older models for their structure? Should we be creating things more from scratch, or vice versa? Do we need to have more peer reviews to catch things earlier? Do we need to do more testing? These are elements that can come out of the inspection process that relate to the process side of things. Okay, maybe I'll just mention a couple things on the technical related things here. How many people here have used assertions before? Okay, some people. So what's an assertion? An assertion is a sort of sanity check, a statement of your assumptions that serves as a sanity check that what you're assuming is the case is indeed the case. So when we build a model, and I don't care if it's in VenSim or AnyLogic or some other platform, we're making assumptions typically. When we write an expression as simple as prevalence is the number of infected people divided by the total population, we're making an assumption. What's that assumption we're making there, for example? If I write fractional prevalence is number of infected people divided by the size of the total population, I'm assuming that, okay, that's true. So I'm assuming the infectives are part of that population, right? That they're a subcomponent of the entire population. And I've had bugs before in my own models, I think, at least some model, and I think it was my own, where, you know, I've had A divided by B, and I think A is part of B, but it turns out it's not. I forgot to add it into B. And so sometimes I get things where that appears greater than 1. And I say, how could that possibly be? I just forgot to add it into the denominator. Another thing I may be assuming is the total population is not 0. And it's not going to work if the total population is 0. So we're making, when we write our code, when we write our formula, or we write our Java code, we're making assumptions all the time. And the goal with assertions is to explicitly document our assumptions, but more than that, to make sure that they are operationally checked, at least when the code is still in development. that every time we run it, they're checked, such that those assumptions, if they are questionable, or if they are false, if they are misguided, will be alerted to that as soon as possible. Because if we have made an assumption that is not grounded, that is not true, we want to know about it as soon as possible to fail early. We want to fail often, we want to fail early so that we can correct our model. It's not pretty, it's not fun to find these things, but it's important, and you should actually view it as a really good thing, because it quickly helps us move towards a correct model. So these assertions document our assumptions, and they reduce the likelihood that errors will slip through. They reduce debugging time, and they help improve the thoroughness of tests. Okay, so we can quickly discover, for example, in a test when assumptions are off. So for example, if we have a model in AnyLogic where we have individuals associated with the coordinate x and y, we may ask, okay, is this a legal set of coordinates? Or did we accidentally create these people outside the legal area? Or did we somehow move them outside of it without checking? We want to make sure they're in the legal area. If so, we'll return a value for sort of where to find their information. So here we have an expression which only works if they're in a legal place, and we make use of that. Or we may want to confirm that something has been computed before we use it. Something is non-null before we go and we try to save it away somewhere. You know, we might do a computation, and we might check something we think is true, always true from the results of the computation. For example, make sure that we're not computing a neighbor that's in fact ourselves, or something like that. So it turns out you can enable assertions in AnyLogic. Within the experiment, you can go to Advanced, and in the Properties, Advanced, and you can go to Java Virtual Machine arguments, and you can do enable assertions. And if you can just put assertions down, it lets other people reading your code understand what you're assuming. It lets yourself be reminded, and it actually makes these things checked whenever that code runs. So that's really good. Now there's a set of other sort of elements of defensive programming that I'll put here. Try to learn indentation style for Java. I know many of you are not from computer science background. And it matters how things are indented, not in terms of how the compiler runs, but in how well people can understand your code, including yourself. Good indentation really communicates the structure of the code, really communicates what's going on. So try to use indentation well, so formatting. Naming conventions are one of the most powerful things you can do. By naming something well, you can take a lot of guesswork out of your model, a lot of wrong guesses out of your model, and it can allow you to zero in on problems sooner. Try to avoid constants. Try to avoid littering your code with constants. Instead, make them parameters, make them variables, give them names. Instead of having 99 in one place and 100 in another, where the 99 is somehow probably derived from the 100, but you're not sure, you know, give the 100 a name of the parameter. Maybe it's the width of the space, and the other one is width minus 1. It'd be a lot more robust, because then you can go change the width without breaking your model. If you have condition checks again and again and again in your model, the same condition is being checked, like, am I within bounds? Create a method that does that and say, is within bounds, X and Y, or something like that. Try to break up your code into smaller bits and call off to methods. Check return values, where to make sure they're legal. Always handle all cases. If you have like handling different enums, try to make sure you handle a bunch of different cases. If you have an if statement, even if there's only one thing inside of it, put curly brackets around it, because sometimes you put in haste another statement there without remembering to put in the curly braces, and the semantics is off. It may be indented, but you don't see it, that it's actually not within the if. So putting curly brackets within the if means if the if is true, all the things inside the curly brackets will get executed. And that's more robust when you put extra things in. Let's see, other things. Yeah, one good thing is if you're going to write code, you could write pseudocode up front to describe what you're doing, and maybe do it and provide lots of comments. That should be in here, and I'm shocked that it's not. So I'm going to put that in. Use comments. Use comments. Okay. Exclamation point. The good thing is, if you adhere to these things well, you won't need comments much. Or let's put it this way: the comments will be redundant. You'll learn a lot more. So strive for transparent code, abstractions. Bad smells in code. If you start seeing duplicate code, really long code, deep if statements, if, that's a sign that you should be thinking about what could be done to improve this. Maybe it's breaking it up into several different methods. If you start to see lots of special cases, some of these aren't so appropriate, but unclear names are certainly something. A lot of code you see again and again, sort of around a call or something like that. Styling convention, yeah. I think I'm going to skip these things. Right. In AnyLogic, you don't often see it, but see if you can use, if there's certain values that don't change, see if you can mark them final, if there's an option to do that, and that makes it clear that you never modify it, so you can count on its value staying the same. This can be a useful element, and use consistent abbreviation dimensions for your names as well. There's a lot more I could talk about here, but time has run out. So I think I'll stop there. It's unfortunate. There's a lot more material I'd love to be able to cover. There's a lot more material of mine online which covers things that I didn't have time to cover in this course. They include things like debugging. How you debug in AnyLogic. Dylan has just managed to get profiling working with AnyLogic. So if any of you are having issues with models that take a long time to run really slow, you might want to talk with Dylan. I had gotten it running in a previous version of AnyLogic, but it didn't run in this version. Dylan found an alternative way which got beyond the roadblock I'd encountered. So Dylan's your man, and you might want to speak with him, because that can alert you to where AnyLogic is spending its time. Is it something silly, or is it something you can't modify quite so easily about your model, and you might have to look at other options like smaller populations, like one of these reduced scale models we were talking about, or like cutting down the frequency of some events that are firing, or running it without a UI. One point here, if your model has a lot of UI elements in it, it takes a lot of time to display things. You might run it from a parameter variation experiment. It actually runs it without the UI. Okay, so it doesn't actually do a lot of that work, and it may run quite a bit faster. So performance issues, debugging issues are unfortunately I'm not able to cover. There's some discussions of intervention implementations, etc. I've tried to, this semester, have a somewhat different coverage of material in this closing part, so we can have a bit of breadth. But if you do check out my AnyLogic common materials online, you'll find a lot of these extra lectures which may be of use to you. So I want to thank you for your contributions to this course. I've really enjoyed teaching it. And I'm enjoying interacting with you for your projects. I will be having, again, office hours on Thursday. I'll be meeting some people right after today's class for quick questions as well. And I would invite you to set up appointments with me if you need additional time. As I said, the projects I'm hoping could be turned in written form by around the 20th. Let me know if this is likely to be a problem, and we can talk about it. But it would be good if you can spend your holidays without using AnyLogic every day. So thanks a lot. It's been a privilege to be able to have you in this course, and I'll look forward to working with you to get your projects wrapped up. Thanks very much.